Hi, and welcome to IoT Security Focus, a new class of security exploits. I hope you're enjoying your time here at IoT Slam this year. There have been a lot of great speakers, a lot of great topics, everything from analytics to integrating with big data to IoT business opportunities. One thread that I think's been woven throughout all of these talks is that of security, and specifically security as it applies to Internet of Things. What's different about security in the Internet of Things? Well, a lot actually, and that's what we're going to go into. Who am I to be presenting to you today? I'm glad you asked, and thanks for your participation so early in our talk. I'm Brian Geisel, the CEO of Geisel Software, a software development consulting firm that lives at the confluence of the Internet of Things. That is where mobile apps meet web apps, meet IoT devices, or embedded software development. We work to help companies with their devices, with their web and their mobile apps, and the integration of all three of them. Because in today's ecosystem, it's important to have all three of those aspects playing together. And we've got clients that have some awesome products in the Internet of Things space, and we're so excited about the great products that are coming out now in IoT. We think that's one of the greatest things about this IoT revolution. We're really excited about these products. They're products that we couldn't have had 20 years ago with a PC or even a laptop. There are products coming out like the one that attaches to a cow's tail that can measure the tail wag of a cow, and from it determine when the cow's about to give birth, which is important because of how often or how high the mortality rate can be in calves if the farmer's not there during the birth. This couldn't have happened with a big IBM PC strapped to the back of your cow. Or another example, I have a friend who has a device attached to her hip. She calls it her pancreas. She can turn it up and increase the amount of insulin that gets distributed into her body just so she can have a piece of cake, which I will tell you she's quite happy about. Now, laptops were great when portable laptops came out, but you couldn't have done that with a laptop. That's the thing that's great about Internet of Things, isn't it? There are so many new avenues, new things to be explored that we're reaching into now, that we're digging into, new things that we can take advantage of. But that's why we're here to talk about security. Because at the same time, all those new opportunities are new things that a hacker has a potential to get control of. And so the first thing I want you to remember today, as we're talking about security for IoT devices, is that new features means new exploits. So we're excited about all the new features that we have, new ways to access data, new things that these devices can do, new places where these devices live. But as a result, we're seeing more and more infiltrations. We're seeing more and more exploits of these devices. Because the devices are becoming more powerful, they're able to do more things. For example, recently a device came out that's a baby monitor. You put it in your child's bedroom to watch your child sleep, and you can connect to it remotely from the internet, not just from the other room, which is great if you've got a newborn at home and you need to go on a business trip and you'd like to just check in on your kid every once in a while. What a great device, except it's shipped with poor security out of the box. Someone, merely to expose the bad security, actually put up a Google map that showed all of the devices around the world that had shipped, where they were physically located, and if you clicked on it, you could look into a child's bedroom. That's a little creepy. But those are the kinds of things that are being exploited as we're adding new features. A new feature to be able to watch into my own child's bedroom means a new exploit opportunity for someone else to watch in. And so how important is the security in this space when we're talking about even our own children who could be at risk? And so as we talk about new features means new exploits, what is it that you're adding? What is it that your device does that's new that could potentially be a avenue for breach? For example, earlier this year, a journalist for Wired magazine worked with 2 white hat hackers to see if they could hack his connected Jeep. And so a white hat hacker, of course, is a hacker who does it in a legal sense, does it not to do an exploit, but rather to present to the company. In this case, they went to Jeep and explained how they did their hack so that Jeep could resolve the problem. And so he set about with these 2 white hat hackers to see if they could hack his Jeep. And while he was driving down the highway, not only did they turn on his air conditioning full blast, not only did they turn on the radio, change the station, and blare it as loud as they could while he was in traffic, they were able to put their own video feed on his DVD control console, his nav console, and at 70 miles an hour, they were able to disable his car and shut down the engine. He had to find a way to get off the highway without any control over his engine safely without having an accident. So what's new? Cars aren't new, brakes aren't new, air conditioning's not new, radios aren't new in cars. So what's new? Well, the car was connected. So with IoT, we're interested because we've got all these devices and they're connected. So even if it's an old device, like a car that's been around for a while, once we connect it, we provided a new feature. Jeep didn't connect it for no reason, right? They wanted to be able to add new features to their product, which makes sense. But in so doing, they provided an avenue for someone with malicious intent to get in and to exploit that new feature that they added. And so we need to be thinking about the things that these devices are able to do, which we're already thinking about because that's our plan to market, right? That's our value add from our company. That's what we're adding into it. So as we look at what is it that they can do, where is it that our devices are, we want to also assess the threat level. So sort of like an insurance company, let's think about this from the standpoint of what is the likelihood that this will happen and what's the worst thing that will happen if my device is in fact compromised. Let's look at one that's not such an issue. I'm not a big fan of the scare tactics of security. I don't want to make this a big thing to blow up. I just want to talk about the truth. So let's look at a case that's not so bad. There are plenty of video games out there, whether mobile apps or Xbox or PlayStation games, that have a Hall of Fame. Very often, you'll see the #1 person in the Hall of Fame has a score of 987654321, and then their name. They probably didn't score that in the game, so what happened? Well, they came to realize that the method in which they uploaded their score to the server was not secure. And so because their device, their Xbox or their mobile app, can upload the score, then they can upload the score. And so they went and set a score of 987654321, which of course translates into English as, "Hello, and I hacked your Hall of Fame." And they send that to the Hall of Fame server, which of course distributes it to everyone else to see that this game didn't do so much to secure their Hall of Fame. All right, so it's a game. Is it a big deal? Probably not. Your game looks probably a little cheaper because someone was able to do that, and it means you didn't spend appropriate time on the security. But did anyone get injured? No. But for your Internet of Things device, you need to think about what can that device do. For example, if it's a large, heavy piece of equipment that's deployed in a factory, is it fast moving? Does it carry large, heavy objects? Then could it potentially be a risk to other humans who are in the factory? You need to think about what are those things that my device could do if I took it over and I used it with malicious intent. Okay, so the other part of that equation for our insurance company scenario is what's the likelihood that we're going to be hacked? So the first thing that we need to think about here is, for example, at Geisel Software, we have some nonprofit customers or clients that we help out. And one of them in particular has a website that was provided to them by someone else, and we've offered to come in and help them with it. And so they called us the other day because it had been hacked. So we went and removed the access and the hacking and so forth and cleaned up the site for them. But their president asked me, Brian, why would someone hack us? We do good things. All we do is good. Why would we be a target? And so, of course, I explained that they weren't the target, their website was the target. Because the hacker can use their website to make a profit. They can replace the website of the charity with a website that sells illegal drugs or something else that the hacker's able to then monetize in some way. And so when we think about the motivation of hackers, it's very often monetary based. What can the hacker get out of it? How can they sell this service, or how could they monetize it? When we're talking about monetizing it, don't just think of credit card numbers, for example. Reuters recently had a statistic out that a medical record is now worth 10 times what a credit card number is worth on the black market. So that means if you're in the medical space, your data, which hopefully you already knew was very important to protect simply because it is people's medical information, but medical records are now quite valuable in terms of monetary gain for that hacker. And so we need to be thinking about that and understanding that we could be a potential target if we're in the healthcare space. Why else? What else motivates hackers? Well, there's plenty of other things. Activism, of course, if you know your company is a target of activism, then you need to be cognizant of that and make good decisions about your security, because you're going to be more of a target than simply because they are targeting you for whatever reason that may be. And then there's always curiosity. What can I do with this thing? For example, things that are cool. Amazon's released some information about drones that they're going to start delivering with, right? These quadcopters, or maybe there's an octocopter. Wouldn't it be cool if I could take control of the Amazon delivery device and then I could do whatever it is that you think you might be able to do with that? So there's a curiosity aspect. It would be cool if, as a hacker, I could do this thing. And so there's always going to be some interest there. So think about what the motivation is for your device. Remember that it's not necessarily about you. It may be about what the hacker can glean from it, what they can get out of it. And that provides an impetus or a reason for them to be targeting your product or your company. So how can I assess my own product's security weaknesses? How can we figure out what those are, especially when our product's a new product? It's never been out there before, so I can't see what somebody else is doing to fix the security. How do we assess it? Well, I'm going to come right back to this, and this is going to be a recurring theme here today. New features mean new exploits. So you've got to go back to what is your value add, because most likely your value add is your Achilles heel. It's the very thing that you add to the market. Your market differentiator is the thing that's going to be targeted, because to a hacker, that's the new thing that I can control, that I can take advantage of, that I can monetize. And so you need to look at what is that thing and how can it be taken advantage of. The camera in the child's bedroom, for example, it's not new to have a connected camera, but perhaps it's new to have it in someone's bedroom. So we need to think more about the security, and in that case, even make our customers more aware of how they can make their own usernames and passwords more secure. So the other aspect that's unique to Internet of Things with our own devices, that's different with software in general, is that when we deploy Internet of Things devices, we've shipped half of our software out into the wild. Your source code now, half of your source code resides with the world. So for a hacker to take a look at your source code and figure out how does your device work, we may say, well, it's hard to get into our device. People will get into your device. You have to assume that someone gets in. How can you mitigate the risk when that happens? You might say, well, we use a compiled language. We use C, or we use C++, or we use Java that's compiled to bytecode or something else. And so they wouldn't have access to our source code. It doesn't matter in that case. Even then, you can disassemble the code and get access to the assembly code and see what those encryption algorithms are. Any security through obscurity can be found out in those instances. And so you need to remember, in the Internet of Things, when your devices go out into the wild, you've released your own source code. So what do we do about it? How do we fix this problem? How do we close those security holes? How do we close the gaps in security? And so there are a number of answers to that question, but I will tell you this. First and foremost, most device security begins in the factory. So hopefully you have a factory plan, right, that includes testing your devices in the factory. In fact, your devices, because they're connected devices, right, you can take advantage of that in the factory. And so you can automate a lot of the tests. You can verify what the factory workers are testing by sending it up to a centrally located server in the factory that gets your factory data. So hopefully you're already doing that, because that's going to be a big part of your security, just that you know that the devices are shipped as they're supposed to be, that they're successful, that they were made correctly, and that they are in fact ready to go out into the wild. But more than that, it's the process in the factory that can be an issue in security. So let's talk about this one. This is one of those things in security that I'm surprised we need to even talk about, but I'm reminded time and time again that we must. And this is what I call the Three Musketeers problem. It's when you put one identifier and or password for all of your devices. All the devices share the same unique key to connect to your cloud server. And it doesn't matter how well encrypted that key is once you've distributed it to all of the devices. This is not one for all and all for one. Three Musketeers is a really bad idea in this case. Why? Because all I have to do is compromise one device and I've compromised the entire network. I haven't compromised one device that can be shut off. If you need to shut me off, at that point, all you can do is shut off all your devices. And as I'm sure you understand in your business model, that's going to be a really, really bad day. So let's avoid that. Every one of your device should have a unique device identifier, which is used to connect it to your portal, and obviously a unique password as well. I know it sounds like for many of you are thinking there's no way anyone does that. Well, let's talk about an example, a giant example of this. In fact, the Blu-ray organization put together the standard for Blu-ray, I guess is why they call them that. And that standard included encryption for Blu-ray discs and Blu-ray players, so that you would need to be one of the royalty-paying members who would then get the key to create your Blu-ray playing device. You would need that encryption key to decrypt Blu-rays. And they talked about how much more secure it was than the same system on DVD, and how the movie industry would make so much more money because of how secure it was. Well, because it was a Three Musketeers release, when it got released on Blu-ray players, the physical hardware, it also got released in software. So for example, Microsoft and Apple had players for their operating system that they paid royalties for and got the key and so forth. Within minutes of having released that software for the first time, the Blu-ray key was made available public on the internet. How? Someone took the software, loaded it into a debugger, sat on the encryption routine that decrypted the software, and just waited until it loaded the key. Loaded the key and posted it to the internet. Now years of work was gone. Why? Because one for all and all for one, the Three Musketeers motto ruled. And it completely destroyed encryption for Blu-ray. So make sure that doesn't happen to your devices. Make sure your devices don't use the Three Musketeers philosophy. Make sure every device has a unique username and password. Further, you don't even want to use a serial number for that. The thing about a serial number is they increment serially. So if my serial number is 1001, your serial number is probably 1002. And I'll bet we can all guess the next guy's serial number. And if I can guess it, so can the hacker who wants to exploit that other device. Now, not only does the hacker know the device ID for the device that they purchased, but they know virtually all the other device IDs that you have. And so it's important that the login identifier that you use between your IoT device and your cloud is unique and non-guessable. Same with the password. You need to have a unique password that uses high entropy. Let's go back to the Jeep example for a moment, because this is one of the issues that allowed the Jeep hack. When the Jeep came off the line, its clock inside the computer on the vehicle was set to what we call the epoch. Just a word we use to mean January 1st, 1970. It comes out as time zero, effectively. So the Jeep starts up, 1 second, 2 seconds, 3 seconds past midnight, January 1st, 1970, and then it says, oh, I don't have a security key. I better generate one. Algorithms, being what they are, take an input, and given that same input, will give you the same output. So we need to provide a random key to the algorithm to generate a good password. Well, the random key was taken from the clock. The clock was 2 or 3 or 4 seconds past the epoch on every Jeep ever shipped. So now it doesn't take us long to guess what your encryption key was. We just take that algorithm and we put in 2 and we try that. If it's not that, we put in 3 and try that. If it's not that, we try 4. Got it. Now in reality, I'm oversimplifying a little, but not much, because in software we can decrypt those keys if there are millions of opportunities, which in fact with milliseconds or microseconds or something, there are more possibilities. But still, we have a very limited set. So we could say, well, we'll put a time on the Jeep. We'll let the Jeep know the actual time before it creates its encryption key. Great! No one will ever know when we made our 2015 Jeep, except it's printed on the door. So now, all I have to do is figure out within that month about when did you make the Jeep. And again, I'm going to plug those numbers into the algorithm. I'm going to come out with your encryption key, and your key is not safe at all. So we need to be creating our passwords and all of these things with high entropy. Now, this is something that's in IT in general, and in fact, any developer or software development firm should understand this and understand how to create high entropy passwords for you. It comes from getting the randomness from physical devices, from the physical world, instead of things like algorithms that have to pull them from a clock or something that's going to be in some way static. And so you need to make sure your serial numbers are safe, and you need to make sure that your passwords are safe on the devices. Again, this is all part of your manufacturing process. This has to be part of your factory plan for how you're building and making these devices. The final thing that I want to talk to in regards to the factory is that your factory workers will have a certain thing that they'll test against, that they'll try, that they'll want to do, use probably features and functionality of your device that you don't want end users to use. A factory test of some kind where they might test different pieces of it. It's very easy if I can reset the device to a factory mode then to get access to all those same features that the factory workers did. So you need the factory workers to have access to test them, but you need to delete that off of your device before it goes out in the wild. Notice I didn't say disable, because if it's disabled and could be enabled, then you have the same problem. We need to delete that so that it's not a possibility to re-enable that mode in the wild, where someone could come back and find an exploit where we really didn't test, because security in the factory is not so important, because my factory workers are trusted by me somehow and so forth. And if not, then security is a different issue there. But presumably our factory workers are part of our trust set. And so we're not trying to exclude them. We're focusing on the security when the device gets out into the wild. So we need to make sure that we're not allowing that same loose security mode that we need for testing to get deployed. The other thing that devices need to do in the wild is firmware update. If you aren't able to do a firmware update of all of your devices live that we can push out to the devices, then the problem is you can't fix security issues as they come up, and that's an issue. So clearly, the ability to update firmware in the wild is going to be an important one for your device. That being said, new feature, new exploit. So the new feature that I can download firmware is a new path for potential exploits. Let me give you a different example. Imagine if Microsoft Update was hacked. Every one of your Windows devices goes to Microsoft to request information from Microsoft. Microsoft sends out updates, security patches, etc. for your Windows box. Now imagine someone malicious instead was able to send that code out. Now it's not a quick hack or a small virus. They've now infected every single Windows user in the world. Right? To our knowledge, that's never happened with Microsoft Update. But if it happens to your device, it feels exactly the same to your customers. So if your firmware mechanism for downloading that firmware is in some way breached, then a hacker can put their own code on your devices. Think again about the Amazon drones. If I could take over an Amazon drone, or better yet, if I could take over the download process for the firmware updates for those Amazon drones, suddenly I become the Pied Piper of Amazon drones and they all follow me. That would be a really bad day for whatever it is that they target those drones on, and of course for Amazon, who owns all those drones in the first place. So it's very important that you protect your firmware download mechanism. You absolutely must have one, but you absolutely must protect it. A similar thing happened with the Apple hack here recently when all Apple apps that are submitted to the App Store must come through Xcode. In China, there was a site that was replacing the Apple version of Xcode. Some developers downloaded that, and it inserted malicious code into the apps so that when they were sent to the App Store, then that malicious code was downloaded by perhaps millions of users across the world who were using iPhones, and unbeknownst to them, they were using a hacked version of an app that was perhaps gathering their data or other information. And so it's really important that we have a mechanism whereby we protect the software on the device, both from our firmware downloads, but then also many devices, many chip manufacturers are providing other mechanisms now for you to verify firmware and firmware updates and changes in code and so forth before the device even boots. And so I would encourage you to take advantage of those different products that are available and to focus your security really again on that process and your communication between your device and your server. If I'm able to compromise one of your devices, I'm now able to do anything that device does to your server. So if that device can upload files to the server, then you need to make sure that those files can't be compromised or aren't executed or couldn't do anything negative on the server side. And so you need to take that entire path and secure it, make sure it's secure up and down. In terms of Internet of Things security, there are a lot of things that are still applied to general IT good security practices. But in this case, in the Internet of Things, there are a lot of additional things that you need to take into consideration when you are releasing your Internet of Things devices. So please remember, say it with me, new features equals new exploits. As you add new features to your products, as you add new capabilities, think about what those things are and what would happen if they were compromised and how you can secure them. Be creative, because the hackers will be creative about how they exploit them. So be creative in advance to think about how you can close those holes and make sure that your clients, your customers are safe, knowing that the code that you wrote, deployed, and the ecosystem of Internet of Things is a safer ecosystem because you've paid attention to those security things. Thank you so much. I appreciate you attending. Again, I'm Brian Geisel for Geisel Software. Please feel free to reach out to me on social media and connect. I'm happy to answer any questions you may have about this talk or talks about your software in the Internet of Things confluence in general. Thank you again. Enjoy.